In this video, we solve these two equations, two radical equations that lead to quadratic equations, and then we solve by factoring and checking. In this problem, we're solving an equation, and there's a square root. When you have a square root in an equation, you need to isolate the square root. So our first step will be to subtract x from both sides. So we have square root of x minus 4 equals 6 minus x. Now that we've isolated the square root, we square both sides. That's the trick for getting rid of the square root. Because when you square a square root, you get what's inside or underneath the square root. So we have x minus 4. And on the right-hand side, we have 6 minus x squared. Remember, that's a binomial squared. So you could write that as 6 minus x times 6 minus x and use the FOIL method. Or I'm going to use the formula, which is going to be the first term squared, 36. Since there's a minus sign, we have the minus sign. And then we have 2 times the first times the last. 2 times 6 times x is 12x. And then the last term squared plus the last term squared will be plus x squared. If you need to write it out as 6 minus x times 6 minus x and use the FOIL method, that's perfectly fine. Now we have an equation that has no radicals, and we see we have an x squared term, and we have some x terms and constants. This is a quadratic equation. So we started out with an equation with a radical sign, a square root in this case, and we ended up with a quadratic equation. So this is a radical equation that led to a quadratic equation, which is easier to solve. So to solve a quadratic equation, we have to set the equation equal to 0. Since the x squared term is on the right-hand side, I'm going to move everything to the right-hand side. So I'm going to subtract x and add 4 to both sides, so it'll be a 0 on the left-hand side. So I'm going to have to subtract x. I'm going to put that over here under the x term, and I'm going to add 4. And that gives me 0 equals 40 minus 13x plus x squared. Now personally, I think it's easier to write it where the x squared term's first, so I'm going to rewrite this as x squared minus 13x plus 40. This is one of our easier quadratic equations to factor. So we want factors of 40 that add up to negative 13. That'll be 8 and 5, so minus 5 and minus 8. So we have 0 equals x minus 5 times x minus 8. So we set each factor equal to 0. So I get x equals 5 or x equals 8. Now you can't stop here. The original equation had a square root. Anytime there's a problem with square roots, you need to make sure that the solutions check, especially when you square both sides, because sometimes you get roots that don't check, solutions that don't check. So let's go back to the original equation. We're going to check and see if 5 really is a solution, and then we'll do it again and see if 8 is a solution. All right, so here was the original equation. Now let's plug in 5 for x. On the left-hand side, so we have the square root of 1 plus 5. Square root of 1 is 1. 1 plus 5 is 6. And on the other side, it's 6. So yes, that checked. So now let's go ahead and check the next solution, which is 8. So we'll plug in 8 for x. And that gives us square root of 4 plus 8, which is 2 plus 8, which is 10. But there's 6 on the other side, so it does not check. So this is not a solution. So that means that 5 was the only one that checked. So if we go back up, this one we cancel out. X equals 5 is a solution. So that's the only one that checks. All right, here's another problem. Try this one on your own by putting the video on pause, doing the same steps, and checking each solution. All right, so here we go. We're going to begin by isolating the square root. So square root of x plus 2 equals x minus 4, and then we'll square both sides. So that gives us x plus 2 equals, and then we're squaring x minus 4. So remember, you could write that out as x minus 4 times x minus 4 and do the FOIL method, and you should get x squared minus 8x plus 16. And now we need to set the equation equal to 0 because, again, we've come up with a quadratic equation. So if we have a 0 on this side, I'm going to subtract x from both sides. So that'll be a minus 9x. And I'm going to subtract 2, so that'll be a plus 14. And how nice, it factors. If it doesn't factor, you'd have to use the quadratic formula or completing the square. But this isn't too bad. It's x minus 2 times x minus 7. So we set each factor equal to 0 and solve. So we've got two possibilities, x equals 2 or x equals 7. Now I want you to look up back in the original equation up here. See if you could do that in your head. If you put in 2 for x into the original equation up here, if you put in 2, you'll have the square root of 4. Well, what's the square root of 4? 2. So you'd have 2 plus 4, well, that would be 6, right? Could that equal 2? No. So you could see if you're adding some number to 4, there's no way it's ever going to equal 2, because when you take the square root of something, it can never be negative. So this is not going to check. But you could also go through the actual steps and show that. Let's see if we could do 7 in our head. If we put in 7 for x, you have the square root of 9, which is 3. And 3 plus 4 is 7, and x is 7. That one is going to check. So this is going to check, right? So you can look up here visually a lot of times and tell right away if something's not going to check. Or you could go ahead and show out the steps, which I'm going to show now. We're going to check x equals 2, so if you couldn't do it in your head, and then we'll check x equals 7. All right, so here we go. We're going to check. All right, so we're going to put in 2 for x. And if we simplify that, we have square root of 4 plus 4, 2 plus 4, 6. Not going to check. Nope. So that's how we know that's not a solution. And then we will go ahead and check by putting in 7 for x. So square root of 9 plus 4, which is 7. And I did have 7 on the other side, so yes, that checks. So the solution is only 7. So we were able to check it. We were able to do it in our head, going up to the original. But this is how you would show your work, doing the check. So that's how to do some problems where you start out with a radical, but after you square both sides, you ended up with a quadratic. Now, sometimes both solutions check, and sometimes neither solutions check. So you really just have to check all of your solutions, and that's how you can tell what the real answer is.